At the IROS 2024 conference, Professor Matteo Saveriano and his research team from the University of Trento in Italy presented their latest research, a novel safety-aware energy tank formulation based on control barrier functions. This method can not only improve system stability and safety in the field of robotics, but also provide valuable insights for the design of future automated systems. Professor Matteo Saveriano was also selected for the New Generation STAR project, hosted by NOKOV Motion Capture. After the conference, NOKOV invited Professor Matteo to share his research experiences in the field of machine learning.
I'm Matteo Saveriano, and I'm currently an assistant professor at the University of Trento in Italy. So my background is in control engineering, but then I did my PhD at the Technical University of Munich in machine learning applied to robotics. So my research activity actually, revolves around learning-based approaches for robotics, with trying to enforce some safety, stability properties, and stuff like that. So this paper actually was something that I was thinking about this since maybe a couple of years, and so I didn't have the time to focus on that. And then finally, I met a PhD student at that time from University of Munich, where I also did my PhD, supervised by Professor Dongyi Li, now at the University of Vienna. So we were brainstorming a bit on the idea, and then actually we found a way to implement this approach. So what's the key core of idea of this one? Actually, when you talk about safety, many people try to reduce the energy exchange between the robot and the environment. But in many situations, it's also the power that is actually the derivative of the safety that matters, because you can dissipate a lot of power instantaneously and still be unsafe. Then we actually reformulated the traditional approach, that is the energy tank, using control barrier functions to basically ensure that we can put limit on the energy and power. And also our approach is, another advantage of our approach with respect to the state of the art is actually that we can guarantee smooth transitions in the energy and in the power, which makes it even more safe. Actually, at the beginning, we had the idea to have to formulate the problem differently in a much more complicated way, because we were thinking that using a simpler formulation would not have been enough. But then in the end, we realized that everything we were trying to do with the complex formulation could have been done with a simple one. And then we also, found some literature supporting us and so on. And then in the end, basically we changed our direction towards the formulation that has been published. We are coordinating some European projects, among them Inverse and Magician. Currently, I supervise one postdoc and 2 PhD students, and I have open calls for 2 more PhDs, for 2 more postdocs. So please, if you want to work on learning based robotics, contact me.